So let's have a look at that again. This is about volume conservation. And around each sea level or water height or water thickness point, we can place a control volume. And this is only shown here in the wider. It's the equivalent feature also happens in the y direction. This is the x direction. X direction is shown here. You look from the side, you have your control volume. Okay, so you are in a region. You have a certain thickness of your fluid. H is the total water depth, and now you move volume into your control volume, or you export volume from your control. Okay, so now what you have to do is you have to look on the right side, the eastern face. Okay, and now it depends on the velocity, on the direction of your flow, which H value you use. If the UK is negative, means the flow comes from east to west, you use HK plus 1 and move it into your control volume. If the velocity here component is positive, means you use HK value and move this out of the domain. And equivalent on the left-hand side, left face of your control volume. And now you can express that with many if statements or so, but there's an elegant way by, no, you don't need to use if statements if you just use these type of things. I talked about that before, just that you're not getting too confused. What does it mean? These vertical lines here means it's the magnitude. Something is negative, it turns. And if you do this, you actually have a values here. This UK plus is same as the U if the U is positive, or it turns to 0 if the U is negative. You sort of have a switch with these formulations. This U minus is defined by it equal to the negative value if U is negative, or it switches to 0 if U is positive. And that's just a little trick of just a okay, so this is what we call the upstream approach here, because it's dependent on the direction. The direction of the velocity component determines which grid cell you use in your calculation.